This is the infrared line follower for our Elegoo robot. In this presentation, I will give you some information on how the infrared switch or sensor works. And to keep things simple, I'm just going to call it a sensor, even though a sensor really senses an infinite number of values. It's technically a switch because it only returns a value of 0 being on and 1 being off. Or the other way around. And we'll see when we get into the code what I actually mean by that. So first, how does this work? There's an infrared sensor, and using the mouse, I'll show you this right here is the sensor. It has an infrared LED, and it reflects off of the ground and is sensed by this switch right here, which is a infrared transistor. It turns it on. And then this LED will light up when it detects the floor. It will send a 0 signal to the microcontroller. Now it lights the LED, but when it detects the floor, it sends a 0 to the microcontroller. So that's what I'm saying. When it actually detects the floor, it sends a 0, which really means off. So in this case, we can think it's off of a black line. When the infrared light does not reflect to the sensor, so let's say that this is over the black line absorbs the light and will not reflect back. That sends a 1 to the microcontroller, and it does not light the LED. Now what does the 0 and the 1 mean? When the infrared sensor board sends a 0 to the microcontroller, it says that it detects the floor or that it does not detect a black line. When the infrared sensor sends a 1 to the microcontroller, it is saying that it detects the black line, which is the correct state that we want it to be in. We want it to detect that black line. Now we can use some conditional statements like if, then, or while to react to these changing conditions. For the program that we're going to write now, we're going to use the if conditional statement because it's the easiest to use for now. And we're going to draw a diagram and write some pseudocode first. So follow along. This is where you definitely want to start taking some notes. So how do we expect this line follower to work? Well, your robot has 3 of these sensors, and they're for left, center, and right. These sensors they should be mounted correctly. The left one should be in pin 11 for the version 1 of the robot. The center one should be in pin 4, and the right one should be in pin 2. And the program that I've written is for that. Now, if you have version 2 or version 3 of this Elegoo robot, those are going to be different, and you'll need to see how to assemble it, and you'll have to make some changes to the program. Your center sensor should ride along the black tape. That is how we want it to work, is to stay on the black tape in the center. The left and the right sensor should get us back to putting the black tape in the center sensor. As long as the center sensor is over this black line, our robot will drive forward, and that's what we want to happen. So the pseudocode is if the center, and that's the variable center, is true or 1, which means it's on the black line, then drive forward for 2 milliseconds. Now the part of the pseudocode that I don't have is that we want to turn the motors back off once it leaves this if statement so that it can go back and do some work later. If the left sensor detects the black tape, we need the center of the robot to move left. So we need this center to come back to the left. So we're going to turn left. Again, our goal is to keep this center sensor on the black tape. And that pseudocode is if left variable is true, or 1 in this case because it detects the black line, then turn left for 100 milliseconds. That needs to turn to the left. And then, of course, after this, we need to turn the motors back off. If the right sensor detects this line, saying that, hey, I'm on the line, then if right is true, or 1, then turn right for 100 milliseconds. So we want that right turn to go for 100 milliseconds. So if we go back, if the center is on, it only drives for 2 milliseconds. You can adjust these times to see how they work with your particular robot. If it goes faster, then you probably don't want to go very far. If it's a slow robot, you could probably bump this one, and this delay up. And now let's do the flow chart. We have our terminator for start. I do not have an end terminator because when we remove power, it's no longer in the program anyway. So the program is naturally going to end when you remove power on these Arduinos. It's always going to loop inside of void loop, and so no matter what it does, this is your loop. It's a little wonky on this presentation because of course there's not enough room to make something you can read. So our program starts when we apply power. This is your terminator, and it goes to the first process, which is void setup. Now, just before void setup, I declare my global variables, any definitions that I need for the pin numbers. I actually do that before void setup, but to keep this flowchart simple, it just says void setup, declare global variables, and set pin mode. And turn on motors. You can also set the whether you do digital write to enable the motors, or if you do a analog write to turn the motor speed down. That's going to be done here, and we won't mess with it again in this simple program. Now, once that's done, it does it once in void setup. It goes down and goes to this is taking input. And this is going to read the digital states of pins 2, 4, and 11 for version 1 of the Elegoo robot. That is the right sensor, the center sensor, and the left sensor. And it's going to store it in the variables right, center, and left. Now, once it does that, it loops through and checks the state. If right variable is true, it means that the right side is on the line. Then it needs to turn right for 100 milliseconds, then turn the motors off. Now, it should not do any of these, since right could be the only one that's true. Unless your black line's too big, it's going to go through, read again. Now, let's say that it's on the center. Is right true? Probably not. So it says no. If left is true, no. But is center true? Yes, it's on the center line. So it will drive forward for 2 milliseconds and turn the motors off. Then it cycles back through again. Now, this is your program loop, and it will continue to follow this flow chart. And let's say that this time the left is on the line. Is right true? No, because the left side is on the line. So is left true? Yes, turn left. And it will continue to turn until you get the center back on the line and it drives forward. So that is your flow chart, and that is the end of this presentation. Now let's go look at the code. So if we pull up our line following robot code that you get from the website, this comment, of course, is not correct for this, but hey, I'm not going to change it. I've already done this whole program for you. Everything is as it should, and you can mess around with the delays. You don't have to copy and paste or change any code. I made life a little bit easier for you. The definitions define the pin numbers, and this is how I like to do it. Of course, the Elegoo guys, they used variables, but I don't like to use variables for constants. These are constants. They're never going to change unless I do something to my robot to change it. So you can see that enable the motor is pin 10, N1 and N2 is 9 and 8, all the way down. These are your infrared sensor pin numbers. And of course, this whole thing is done through the port on the Arduino. Pins 2, 4, and 11 are right, center, and left, respectively. And this comment is absolutely wrong. It should go to 1. Of course, hey, I'm fixing mistakes even as we go. It really goes to 1 when it's on a black line. I had it wrong in versions before because I'm experimenting with it too. These are our variables. Right, center, and left. And we're going to use these to store the states of the pins. Now, all of this is done for you. I just want you to know how it works. In void setup, remember this is only run once, and you can go back in the video and look at the flow chart. I've set all the pin modes for the motors to outputs, all of the pin modes for the sensors to input, and then I wrote analog write and made the speed 110. You can play with this number. you can make it from 0 to 255, 0 being off, and 255 being blazing fast. And you're going to have to chase your robot. All right, time to change classes. Yay! All right, so void loop is the loop where we are actually going to do the whole program. So the basic line reading code looks like this. This is your taking input right here. This takes input from the sensors and stores them in right, center, and left. These can only be a 0 or a 1. So if right equals 1, means that right is on the line, we need to turn right, and I like tank style turns, so both motors are going to turn. It turns right for 100 milliseconds, there's your delay, and then it stops the motors. Then it flows through the program and it'll start over. Now let's say if left equals 1, then it's going to turn left using both motors. It will delay for 100 milliseconds, and then it stops the motors and continues through. Now the final thing is if center equals 1, then it should drive forward for 2 milliseconds. Now where you can mess around with this code is messing with the speeds. You can mess around with the delay right here in each of these and make them longer or shorter and see how it reacts. And you can adjust those. If you make it fast, you want to make these smaller. If you make your robot go slow right here, you can make these a lot larger because your robot's going to cover less ground at that speed. So this is how to make a line following bot with an Elegoo robot. You can take this video and work through it and make sure that you understand how everything works and the flowchart works, and you can see that this program flows just like that through the program. All right, have a great one and have fun with your line following robots.